In another example of free body diagrams, let's look at a slightly different kind of situation, and that is one where the pieces that are holding all the system together seem to be a little bit more intricate, and how do we handle some of those aspects of things, right? So what we're going to do is we're going to focus really on this ring at C and a little bit of the fixture that's happening here at the points of contact at A and B. This is a 500-pound drum, not a 500-gallon or a barrel or anything like it. The weight of this drum or barrel is 500 pounds, which automatically means that we are lifting up here with 500 pounds. That's the lifting chain, and then we've got the center of mass that presumably is right below. Now, if it's static equilibrium, it has to be, otherwise, I didn't quite get that over there. There one's a little better, not a lot, but let's go with it. Hey, if I just make this big enough and thick enough, then it'll line up, right? It has to be, right? Because if it doesn't line up, we've got then this readjustment that's going to happen. It's like a pendulum. It'll finally settle down so that those two are right in line with each other, right? And that's your weight, 500 pounds. Okay, so let's look at what happens when we go through and we cut right here at point C that ring. Alright, so let's get the ring here. Bam. Alright, now on that ring we have the chain, and that of course is our 500 pounds pulling up. Alright, so 500 pounds pulling up. Now we've got this cable that wraps around. Right now we're told that we have equal length cables. That just means from A to C is the same length as from C to B. That tells us a lot about the triangle that's here, that whatever is going to happen, the line of action here is going to be the same in both directions, right? Because we've got basically an isosceles triangle that's working itself out. And I haven't calculated any angles or anything yet. I don't know what that's all going to be like, but we've got essentially here a triangle where you've got 16.5 inches here, 16.5 inches there, and 15 inches on the vertical, right? So this angle and that angle are the same, and that angle and that angle would be the same, right? That's what the equal length is telling us. Now, this cable that wraps around, or wire or rod, goes from B and wraps around C and comes back and is reattached, right? And so what that tells me is that when I cut this right here, I've got two values going to the right, where the individual one is just T, so I got two of those, right? We could call that cable BC. And then the same thing over here, we've got two of them, and because it's one cable, that's why it has to be the same in both. That's why it's just 2T, let's call that one AC. And that's your free body diagram of the ring. Right now, there's other little pieces here. Because a sum of forces in the x has to be 0, then the x components of these have to be the same, and since they're at the same angle, well, gee, that means TBC actually has to be equal to 2AC, so you could have just said 2T and 2T. Now, the only way that really works, or proving it, you've got to sum forces in the x to get there. And then that also tells you that these vertical components here then are going to turn out to be the same because they're at the same angle as well. Kind of interesting. The vertical component then is going to have 4T, 4 components here. 500 divided by 4 is 125. That is going to be the vertical component, but we got to swing that over onto the hypotenuse in order to figure out what that is. That's going to be a larger value, and because this thing is at about it's kind of at about 45 degrees, not quite, right? It's a little bit flatter than a 45 from the horizontal. 42 and change maybe. I don't really know that. I just kind of have done this problem, so I know that's 42 and change, and that's 47 and change. Indeed, that's about 47.7, 42.3. Right? But from a free body diagram standpoint, that's what we've got. It's a little simple concurrent force system there. Now the bracket at B, interestingly, would then, let's draw something that is going on with the physical bracket at B. Right? And it's got a little clip here, and then it's got the little bracket that comes up, and these cables are attached to this little part here, and you'd have a total now of 2T going on there. And in order for equilibrium to be happening, there's a pretty complex thing that's probably going to go on. There's got to be some vertical component, there's got to be some horizontal component, and because these are offset from there, there's probably some sort of, let's see, if some moment's about here, this thing would want to spin that way, so there's some sort of resisting moment there on that bracket as well. That's kind of complicated, isn't it? That's what you get into when you start looking at the bracket itself. Right now, if you wanted to look at the barrel, you could actually simplify this down a little bit. We've got the barrel or the drum, whatever you want to call it. And here, if I include the bracket in the free body diagram, I make this a lot easier. If I don't, then I got to put all three of those little pieces, right? One of Newton's laws, for every action there's an equal opposite reaction. But if I include the bracket, I make life a lot easier, right? You go to the center of mass to represent the effect of the weight. I made that a really big, bold vector before. That was only because I wanted to make the drawing look like it really lined up. I just got a little sloppy there. Right, so there's your 500 pounds. That's the driving force in this whole system. And then we just take the opposite end of the cable, like we got here. There's your 2T. There's your 2T. You could do your analysis on the system this way if you wanted to. I don't. I prefer to do it with this ring because that's just a little bit easier to kind of work with in how all the stuff works. Just to my eye looks the same or easier, but either one works equally well in the end on if you want to find numbers. But that's just a little bit more about drawing free body diagrams in this slightly different kind of situation where you don't see any reaction. You just have to pull apart the pieces of the system.